Cool, and that's it with our first topic. So let's move on to the next topic, which is discrete mathematics. So this topic is revolved around looking at graphs, specifically network graphs. So this topic is actually very important for year 12, and next year you'll be building on some of the principles that you learned this year. So I would highly encourage you, everyone, to ask questions if they don't understand anything. So first of all, what is a graph? So a graph is actually just a way of representing information. That is literally it. So in unit 1, you would have looked at matrices. So matrices was a way of representing information. Networks is also just another way of representing information. However, matrices was a more mathematical way of representing information. Graphs are more diagrammatic. Okay, so we have two separate types of graphs. So we have undirected and directed graphs. So let's look at undirected networks first, and what are some of the features. So undirected network is a graph that consists of a set of points called vertices that are joined by a set of lines called edges. So these here are the vertices. So the specific points, or the specific, so for example, if we're looking at a map of something, the vertices might be the specific locations in a map. So that is what a vertex is. And now the edges are the lines that connect the vertices. And the edges are essentially what's representing the information. They represent the relationships between different vertices. So if we have a connection using an edge between two separate vertices, it indicates that those vertices are related to each other in some way, in some way. So that is what a vertex is, and that's what an edge is. So, and then what do we have here? So here we have an isolated vertex. So pretty straightforward. Isolated means it is not connected to anything. So there's no edges going off of it. Now, a specific notation that you need to know is something called the degree of a vertex. Okay? So the degree of a vertex essentially corresponds to the number of edges specifically going off of one vertex. So for example, looking at this vertex over here, on the left, this one, what would be its degree? So its degree, to work out its degree, all we need to do is count the number of edges that are attached to it. So 1, 2, 3. So therefore it has a degree of 3. What about this one? This one has 2 edges going off of it. So therefore its degree is 2. Now what about this one? Now this one is a bit different. Now you might think 1, 2, and the last one is something we call a loop. So this is also a type of edge which connects a vertex to itself. So it's an edge which connects a vertex to itself. Now a loop actually counts as 2 separate edges because technically we have one going this way and one going this way. So a bit strange, but it counts as 2. So therefore this vertex has a degree of 4. Okay? So that's all that a vertex, that's all that a degree refers to. Okay? So another terminology that you need to know is face. So a face refers to essentially the enclosed regions between vertices and edges. Okay? And often you'll get question asking you to work out the number of faces that a particular graph has. Okay? So all you really need to do for these ones is go around the graph and look at the number of enclosed regions there are. So in this graph, we have 9 faces. So 1, 2, 3, 4, 5, 6, 7, 8. And now you might be wondering where the 9th one is. So in networks, we actually consider the space around a network a face as well. Okay? So therefore, this network has in total 9 faces. So now let's look at the different types of graphs that can exist. So first we have simple graph. So a simple graph is a graph which has no loops, no multiple edges. So a multiple edge is basically when two vertices are connected by one or more edges. So for example, if we look at these two vertices, if there was another edge connecting them, that would be a multiple edge. So simple graphs have no multiple edges, no loops, and the sum of degrees of all vertices will be even regardless of number of vertices. Okay, so this is some of the criteria for a graph to be simple. So what the third criteria basically means is if you sum up all the degrees of each of the vertices, it should be an even number. If it's not, then it's not a simple graph. So here's an example. So we've worked out the degrees of all these vertices, so completely ignore this edge over here. Okay, and if we add that up together, we get 12, so therefore this is a simple graph. So it has to meet not one of the criteria, but all of the criteria in order to be a simple graph. This graph, you can pretty much ignore. I've just put it here because there has been a question in the past, but this one, like, I've never come across this ever, studying general maths. So a degenerate graph is basically a graph in which every single vertex is isolated, which basically means that the graph has a degree of 0 and that the graph has one face. And the one face is the infinite face because there's no enclosed regions. Next, we have connected graphs. So connected graphs are graphs where the path between all vertices exists. So there's a path between all vertices. There are no isolated vertices. So that's the main criteria for a connected graph. There is no isolated vertices. And in order to be a connected graph, the minimum number of edges that it needs to have is n minus 1. So that n represents the number of vertices. So if something has 8 vertices, it needs to have at least 7 edges. Okay? In order to be connected. And that makes sense as well. So that just ensures that there is nothing isolated. Unless there are multiple edges. But yeah, so both of these criteria need to be met. No isolated vertices, and the minimum number of edges needs to be n minus 1. Okay, so then we have a complete graph. So, Okay, so a complete graph is basically a graph in which every vertex is connected directly by an edge to every other vertex in the graph. So basically what that looks like is, it's a graph where if you have one vertex, it will be connected to every single vertex on that particular graph. Okay, so as we can see here, so this is connected to this one, it's connected to this one, it's connected to this one. So that's what a connected graph is. Every vertex is connected to every other vertex in the graph. And the number of edges in a connected graph can be found by this rule. n minus 1 times over 2. And this is like a shortcut. So to determine the number of edges that a connected complete graph will have, you just apply this formula. So for example, for this one, we have 1, 2, 3, 4 vertices. So n is equal to 4. So applying this formula, that will just be 4 minus 1 over 2, which will be 4 times 3 over 2, which will be 12 over 2, which is 6. So therefore, this graph will have exactly 6 edges, and I don't even need to count them. Excuse me.